A KVM switch traditionally is a hardware device, now more commonly software, that allows a user to control multiple computers from one or more keyboard, video monitor and mouse. Hardware KVMs connect a smaller number of computers together and are typically port and distance constrained. Virtual KVM Switch Virtual KVMs are replacing hardware KVMs in most applications outside of the enterprise data center. Virtual KVM is computer software installed on networked PCs to create a virtual keyboard and mouse switch where the mouse cursor can be seamlessly moved across multiple PCs, each with their own monitors. Virtual KVM uniquely integrates multiple remote computer access and control with its seamless capability. In KVM or remote mode, multiple computers can be controlled from a single computer while sharing a single keyboard, mouse and monitor. The controlled computers are not required to have an attached monitor, keyboard or mouse. Any combination of seamless and remote modes can be simultaneously active across multiple computers. Virtual KVM switches do not require any switch boxes or cables to operate. It is an easy-to-install software solution that simply works without the need for transmitter and receiver hardware components installed for each computer. Virtual KVM switches do not have peripheral, resolution or distance limitations. Virtual KVM switches are compatible with any peripheral type or combination, including HDMI, DVI, VGA, SVGA, DisplayPort, PS2, USB. Network and keyboard mouse connectivity can be wireless or wired. Virtual KVM switches provide unique capabilities, data compression and encryption services to transfer data quickly and protect sensitive data passed between computers, video compression and multi-core video processing for fast video transfer and rendering, independent audio transfer so that audio from multiple computers can be received and listened to from the primary computer, file, folder, video and image data transferred between computers, virtual machine support, on-network computer access, on-screen remote computer monitoring and access, mouse scroll, hotkey and touch screen switching, and other capabilities as provided by multiple market players. Etymology: before mouse became relevant in server switching applications, keyboard video switch was used to describe keyboard and monitor switching devices. With the increased adoption of Microsoft Windows, the mouse and other I/O ports in peripheral switching became prevalent. Remigius Schitters, the founder of Cybx, expanded the initialism to keyboard, video and mouse in 1995. At the same time, Universal Serial Bus had been becoming the new industry standard for computer peripherals to computer systems. After Windows 7, released in 2009, caused the standard touchscreen built-in interface driver of Windows 7, the USB HID devices sharing had become the new focus of new generation of KVM switch. As a result, the KVM switch is also called KVMP/KVMT, T for the touchscreen switch or called console sharing switch. Types: with the popularity of wireless keyboards, mice, and networks, virtual KVMs are quickly becoming the most common type of KVM switch. As KVM switch technology has matured and been required to meet the differing market needs, classes of KVM switches have been reviewed and are based on different types of core technologies in terms of how the KVM switch handles USB I/O devices including keyboards, mice, touchscreen displays, etc. These comparisons are all based on the legacy hardware approach to multiple computer control with one keyboard and mouse. Virtual KVM switch, also called a software KVM switch, is installed on networked PCs to create a virtual KVM switch with two modes of operation. In seamless keyboard and mouse mode, the mouse cursor can be freely moved across multiple PCs, each with their own monitors. In remote keyboard, video, mouse mode, many PCs can be controlled from a single PC while sharing a monitor. The controlled PCs are not required to have an attached monitor, keyboard or mouse. Any combination of seamless and remote modes can be simultaneously active across multiple PCs. Virtual KVMs are cableless, peripheral type independent and do not have distance limitations. USB Hub Based Kvm, also called an enumerated KVM switch, A connected shared USB device must go through the full initiation process every time the KVM is switched to another target system port. The switching to different ports is just as if you were to physically plug and unplug a USB device into your targeted system. Emulated USB KVM, dedicated USB console port, S, are assigned to emulate special sets of USB keyboard or mouse switching control information to each connected targeted system. Emulated USB provides an instantaneous and reliable switching action that makes keyboard hotkeys and mouse switching possible. However, this class of KVM switch only uses generic emulations and consequently has only been able to support the most basic keyboard and mouse features. Semi-DDM USB KVM, dedicated USB console port, S, work with all USB HID devices, but do not maintain the connected device's presence to all of the targeted systems simultaneously. This class of KVM takes advantage of DDM technology. DDM USB KVM, dedicated USB console port, S, work with all USB HID devices and maintain the connected device's special functions and characteristics to each connected targeted system. This class of KVM switch overcomes the frustrating limitations of an emulated USB class KVM by emulating the true characters of the connected devices to all the computers simultaneously. This means that you can now use the extra function keys, wheels, buttons, and controls that are commonly found on modern keyboards and mice. Limited equals supported, but does not allow USB re-enumeration, which not only causes long delays in switching, but also sometimes causes HPD errors to the OS system. Yes equals latency time within 1 second while switching between channels ports. Use KVM switches are useful where there are multiple computers, but no need for a dedicated keyboard, monitor and mouse for each one. They are frequently used in engineering, software development and testing, command and control desks, and data centers where multiple computers are accessed with a single keyboard, monitor and mouse. A KVM switch then enables control of any connected computer. A common example of home use is to enable the use of the full-size keyboard, mouse and monitor of the home PC with a portable device such as a laptop, tablet PC or PDA, or a computer using a different operating system or in a different room. KVM switches offer different methods of connecting the computers. Depending on the product, the switch may present native connectors on the device where standard keyboard, monitor and mouse cables can be attached. Another method to have a single DB25 or similar connector that aggregated connections at the switch with 3 independent keyboard, monitor and mouse cables to the computers. Subsequently, these were replaced by a special KVM cable which combined the keyboard, video and mouse cables in a single wrapped extension cable. The advantage of the last approach is in the reduction of the number of cables between the KVM switch and connected computers. The disadvantage is the cost of these cables. The most common approach is the virtual KVM, which eliminates the need for cables and is significantly less expensive than hardware/cable-based KVM switches. The method of switching from one computer to another depends on the switch. The original peripheral switches used a rotary switch while active electronic switches used push buttons on the KVM device. In both cases, the KVM aligns operation between different computers and the user's keyboard, monitor and mouse. In 1992 to 1993, Cybx Corporation engineered keyboard hotkey commands. Today, most KVMs are controlled through non-invasive hotkey commands. Hotkey switching is often complemented with an on-screen display system that displays a list of connected computers. KVM switches differ in the number of computers that can be connected. Traditional switching configurations range from 2 to 64 possible computers attached to a single device. Enterprise-grade devices interconnected via daisy-chained and/or cascaded methods can support a total of 512 computers equally accessed by any given user console. With virtual KVMs there is no limit to the number of computers that can be connected or controlled, and because virtual KVMs are cableless there is no need to physically daisy-chain anything. Multi-way channel selection can be found with KVM switches, via built-in IR remote sensor control, via built-in RS-232 port for serial commands and control, via on-mouse click switch, fast switch using some function buttons for system selection, via touchscreen sensing control, video bandwidth. While HDMI and DVI switches have been manufactured, VGA is still the most common video connector found with KVM switches, although many switches are now compatible with DVI connectors. Analog switches can be built with varying capacities for video bandwidth, affecting the unit's overall cost and quality. A typical consumer-grade switch provides up to 200 MHz bandwidth, allowing for high-definition resolutions at 60 Hz. For analog video, resolution and refresh rate are the primary factors in determining the amount of bandwidth needed for the signal. The method of converting these factors into bandwidth requirements is a point of ambiguity, in part because it is dependent on the analog nature and state of the hardware. The same piece of equipment may require more bandwidth as it ages due to increased degradation of the source signal. Most conversion formulas attempt to approximate the amount of bandwidth needed, including a margin of safety. As a rule of thumb, switch circuitry should provide up to 3 times the bandwidth required by the original signal's specification, as this allows most instances of signal loss to be contained outside the range of the signal that is pertinent to picture quality. As CRT-based displays are dependent on refresh rate to prevent flickering, they generally require more bandwidth than comparable flat panel displays. Monitor. A monitor uses DDC and EDID, transmitted through specific pins, to identify itself to the system. KVM switches may have different ways of handling these data transmissions. The KVM switch lacks the circuitry to handle this data, and the monitor is not visible to the system. The system may assume a generic monitor is attached and defaults to safe settings. Higher resolutions and refresh rates may need to be manually unlocked through the video driver as a safety precaution. However, certain applications that depend on retrieving DDC-EDID information will not be able to function correctly. Fake. The KVM switch generates its own DDC-EDID information that may or may not be appropriate for the monitor that is attached. Problems may arise if there is an inconsistency between the KVM specifications and the monitors, such as not being able to select desired resolutions. Pass-through. The KVM switch attempts to make communication between the monitor and the system transparent. However, it may fail to do so in the following ways: generating hot plug detect events for monitor arrival or removal upon switching, or not passing monitor power states, may cause the OS to redetect the monitor and reset the resolution and refresh rate, or may cause the monitor to enter to or exit from power-saving mode. Not passing or altering MCSS commands may result in incorrect orientation of the display or improper color calibration. Microsoft guidelines recommend that KVM switches pass unaltered any I2C traffic between the monitor and the PC hosts, and do not generate HPD events upon switching to a different port while maintaining stable non-noise signal on inactive ports. Passive and active switches. KVM switches were originally passive, mechanical devices based on multipole switches, and some of the cheapest devices on the market still use this technology. Mechanical switches usually have a rotary knob to select between computers. KVMs typically allow sharing of 2 or 4 computers, with a practical limit of about 12 machines imposed by limitations on available switch configurations. Modern hardware designs use active electronics rather than physical switch contacts, with the potential to control many computers on a common system backbone. One limitation of mechanical KVM switches is that any computer not currently selected by the KVM switch does not see a keyboard or mouse connected to it. In normal operation this is not a problem, but while the machine is booting up it will attempt to detect its keyboard and mouse and either fail to boot or boot with an unwanted configuration. Likewise, a failure to detect the monitor may result in the computer falling back to 640x480 resolution. Thus, mechanical KVM switches may be unsuitable for controlling machines which can reboot automatically. Another problem encountered with mechanical devices is the failure of one or more switch contacts to make firm, low-resistance electrical connections, often necessitating some wiggling or adjustment of the knob to correct patchy colors on screen or unreliable peripheral response. Gold-plated contacts improve that aspect of switch performance, but add cost to the device. Most active KVM devices provide peripheral emulation, sending signals to the computers that are not currently selected to simulate a keyboard, mouse and monitor being connected. These are used to control machines which may reboot in unattended operation. Peripheral emulation services embedded in the hardware also provides continuous support where computers require constant communication with the peripherals. Some types of active KVM switches do not emit signals that exactly match the physical keyboard, monitor, and mouse, which can result in unwanted behavior of the controlled machines. For example, the user of a multimedia keyboard connected to a KVM switch may find that the keyboard's multimedia keys have no effect on the controlled computers. Software alternatives. There are software alternatives that provide much of the same functionality of a hardware KVM switch, such as Multiplicity, which does the switching in software and forwards input over the LAN, Wi-Fi, VPN network. This has the advantage of eliminating switch boxes, cables, and extenders and significantly reducing KVM switch cost. Screen edge switching allows the mouse to seamlessly move between two or more computers with dedicated or multiple monitors. As of 2014, Edge Runner has significantly updated Multiplicity, which it now makes available from its website. The application works as a virtual KVM for 2 to 50 PCs, shares data between PCs securely in real time, and comes with true enterprise-grade support, making it a reliable and preferred alternative to hardware KVM switches and remote access software alternatives. Remote KVM devices. There are two types of remote KVM devices that are best described as local remote and KVM over IP. Local remote. Local remote KVM device design allows users to control computer equipment up to 1,000 feet away from the user consoles. They include support for standard Category 5 cabling between computers and users interconnected by the switch device. In contrast, USB-powered KVM devices are able to control computer equipment using a combination of USB, keyboard, mouse and monitor cables of up to 5 meters. KVM over IP. KVM over IP devices use a dedicated microcontroller and potentially specialized video capture hardware to capture the video, keyboard, and mouse signals, compress and convert them into packets, and send them over an Ethernet link to a remote console application that unpacks and reconstitutes the dynamic graphical image. This KVM over IP subsystem is typically connected to a system's standby power plane so that it's available during the entire BIOS boot process. These devices allow multiple computers to be controlled remotely across a wide area network, local area network or telephone line using the TCP/IP protocol. There are performance issues related with LAN1 hardware, standard protocols and network latency, so user management is commonly referred to as near real-time. Access to most remote or KVM over IP devices today use a web browser but can even switch between two or more hard drives, although many of the standalone viewer software applications provided by many manufacturers are also reliant on ActiveX or Java. Security note: some KVM chipsets or manufacturers require the whitelisting, or authority to connect, to be implicitly enabled. Without the whitelist addition, the device will not work. This is by design and required to connect non-standard USB devices to KVMs. This is completed by noting the device IDs, or documentation from the manufacturer of the USB device. Generally all HID or consumer-grade USB peripherals are exempt, but more exotic devices like tablets, or digitizers or USB toggles require manual addition to the whitelist table of the KVM. In comparison to conventional methods of remote administration, a KVM switch has the advantage that it doesn't depend on a software component running on the remote computer, thus allowing remote interaction with base-level BIOS settings and monitoring of the entire booting process before, during, and after the operating system loads. Modern KVM over IP appliances or switches typically use at least 128-bit data encryption securing the KVM configuration over a WAN or LAN. KVM over IP devices can be implemented in different ways. With regards to video, PCI KVM over IP cards use a form of screen scraping where the PCI bus master KVM over IP card would access and copy out the screen directly from the graphics memory buffer, and as a result it must know which graphics chip it is working with, and what graphics mode this chip is currently in so that the contents of the buffer can be interpreted correctly as picture data. Newer techniques in OPMA management subsystem cards and other implementations get the video data directly using the DVI bus. Implementations can emulate either PS/2 or USB-based keyboards and mice. An embedded VNC server is typically used for the video protocol in IPMI and Intel AMT implementations. KVM sharing devices. KVM sharing devices function in reverse compared to KVM switches. That is, a single PC can be connected to multiple monitors, keyboards, and mice. While not as common, this configuration is useful when the operator wants to access a single computer from two or more locations, for example, a public kiosk machine that also has a staff maintenance interface behind the counter, or a home office computer that doubles as a home theater PC. See also, console server, Intel Active Management Technology, Intelligent Platform Management Interface, Remote Graphics Unit, Dynamic Device Mapping, Display Control Channel. References